Well, a prominence. A prominence is a large, bright feature which extends outward into the sun's surface, and this often forms a loop shape. This is because as it extends into the corona, some of the sun's gravity will pull it back. A prominence can form over a time scale of about one whole day, but stable prominences may persist in the corona for several months. Some prominences break out and give rise to coronal mass ejection, which we'll be talking about in the next slide. In 1997, there was one prominence which was 350,000 kilometers long, just about the size of 28 Earth. Here are two pictures of different prominences. There's a solar prominence which is linked to the sun, and it doesn't leave the sun's surface. And then there's a detached prominence which leaves the sun's surface and goes into the corona. Here's a coronal mass ejection, which is just an extremely big prominence. It's an ejection of matter which comes from the solar corona. The frequency of ejections depends on the phase of the solar cycle, from about 1 every other day near solar minimum to 5 to 6 per day near solar maximum. A typical CME, which stands for coronal mass ejection, has a 3-part structure consisting of a cavity of low electron density, a dense core, which is the prominence, which appears as bright regions on the photographic images, embedded in this cavity, and a bright leading edge. Most coronal mass ejections originate from active regions of the sun, such as sunspots and frequent flares. Here's a video of a coronal mass ejection. So as we saw in that video of the coronal mass ejection, there was the birth of the prominence which went into the universe from the corona. And now we're talking about solar flares. A solar flare is a sudden intense variation of brightness. These solar flares occur when magnetic energy that has built up in the solar atmosphere is suddenly released. As the magnetic energy is being released, particles including electrons, protons, and heavy nuclei are heated and accelerated into the solar atmosphere. As seen in this picture, various particles are being ejected all through the solar atmosphere. There's also solar tornadoes. Solar tornado typically lasts about 10 minutes and occurs near the sun's poles, the north and south poles. These solar tornadoes are almost 1,000 times faster than a terrestrial tornado and much bigger. The main element is that the erupting structures possesses a twist. And this twist comes from the sun's magnetic field, but the twist cannot be stored, so it ends up being released. In this picture, we have a solar tornado right here, and then the energy is just being released into the atmosphere of the sun. Now I'm going to have my buddy Derek explain solar winds.
Thank you, Peter. Now let's talk about the solar winds. Solar winds are the constant flow of particles streaming out of the sun's surface in all directions. The solar wind originates from the nebula. Solar winds are responsible for creating the green, yellow, and red lights in the skies near the Earth's northern and southern hemispheres. You can see these lights when you go up north to the Arctic regions of Canada. And these lights are often referred to as the northern lights. So, solar winds are responsible for the anti-sunward tails of comets and the shape of magnetic fields around the planets. Solar winds also cause some devastating effects. For example, they cause geomagnetic storms on Earth. Here we see a diagram of the solar winds. This is the sun's corona, or solar atmosphere, and here is the chromosphere. This is the sun's radiation, and you see how the radiation particles travel to the Earth. This is the Aurora Borealis. The Aurora Borealis is another name for the Earth's northern hemisphere, and we also have something called the Aurora Australis, which is the Earth's southern hemisphere. This, here we see here, is called the Northern Lights and can be found in Canada's Arctic region. Aurora Borealis is produced when the charged particles of the solar wind collide with the atoms and molecules of the Earth's surface, which is basically solar winds from the sun. Here is a video of the Aurora Borealis. I would like to take this time and call Rodney and Peter here to conclude our presentation.
Okay, so I hope you learned some stuff learning. Once again, I want to thank Mr. P on inviting us and explaining and letting us explain the nature of the sun.
Thanks for watching. Goodbye.
Did that answer your question?
It sure did.